Welcome in this video describing the Arcadia method and the Capella workbench with an example. The example is a level crossing traffic control that is used by Jean-Luc Voirin in his Arcadia book. Jean-Luc Voirin is the main author of the Arcadia method. In this video, Jean-Luc will focus on system need analysis, what the system has to accomplish for the users. Based on the operational need analysis, he will explain how to perform functional and non-functional analysis, identify external interfaces, formalize and consolidate requirements.
Let's enter system need analysis now. Here in operational analysis, we have defined the different missions, expectations, activities that the different stakeholders, among which the regulation authority, would have to perform so as to fulfill the missions. Now let's decide what we expect from the level crossing control system itself. So now we have to introduce what is expected from it and what will be allocated to other stakeholders, such as authority actors, station, and others, for example. So we start by missions and capabilities expected from the system itself, similarly to what we have seen at operationalities, but focused on the system itself. Here we can see that we have the same kinds of missions, of course, that we had previously, with different capabilities which are more focused on what we expect from the system. So securing train departure or train arrival, and securing also, especially, which is a specific demand for the system, detect and secure a vehicle that would be stopped on the track. Because, as we have seen, this is part of the feared situations that we want to avoid. And for so, of course, we have different capabilities of second level that we might have to put available so as for the mission to be fulfilled. For example, managing, of course, train departure and arrival traffic, managing and controlling road vehicle traffic, and here again, favoring temporarily road traffic in case of road traffic jam, for example. Let's have a look to how it looks in terms of what is devoted to the system, in terms of services or functions that he has to deliver so as to fulfill those missions. Here we are in a similar view as the one that we have seen previously. We have now the same kinds of stakeholders, but not exactly the same ones. As you can see, we have the road vehicles that have the same kind of behavior. We have a train leaving. Here we focus just on the departure and not more, so it's a bit reduced in terms of scope as compared to the previous one in operationalizes. And we have this train leaving having the same kinds of behavior as well. The station, the railway station itself, is replaced by the station information system, just because now the real external actor that the system we have to interface with will be not the railway station as a whole, but the station information system itself that will be delivering some information to the system itself. And here we have no more the traffic regulation authority, but the traffic control operators, those who are in charge of the real operation of the level crossing. And as you can see, a new element has appeared, which is the control system itself, which is our scope of interest and what we have to design and engineer. So here we have made a first set of choices so as to allocate expectations on the system or on the external actors. Here we can see that the system is in charge of a set of what we call functions, in green here. Those functions are what we expect from the system as differentiated from what the control operators, for example, will have to manage. Here we can see, for example, that we consider that the system should be in charge of supervising by its own the departure procedure. As you can see, the operators mainly monitor the behavior of the system and the system operation, not more. So this means that the whole departure procedure will be in charge of the system itself. Therefore, he will need to verify the absence of vehicle in the crossing. He will have the same own capabilities to release or stop vehicle traffic, for example, and to allow trains to depart or to stop and wait until he decides to free him. So as you can see, we already have here a set of decisions that has been taken from the operational analysis, and we could have several alternatives of system need definitions according to, for example, a low or high level of automation that would lead to moving some functions either from the system to operators or vice versa. Here again, we have chosen a fairly automated situation and a mainly automated level crossing control. Similarly, as operational processes that we have seen previously, we will have a set of functional chains that will describe some path inside the functionalizes that we have seen that focus on one given part, for example, here of the train departure. We have the same diagram, but as you can see, we have defined a set of functional chains that take part of the departure procedure, for example, so stopping road traffic, here in blue, releasing road traffic as well, detecting a vehicle presence on the crossing itself, and so on. So this is a set of parts of the departure procedure that are interesting, not only to describe the expected behavior and the roles of each stakeholder in this departure procedure, but that also will be used later for verification and validation purpose, because we can imagine having a set of test scenarios and test campaigns according to each of these functional chains, for example, so as to demonstrate to the customer that our system fulfills this need as described here. Of course, I have mentioned only the train departure focus here. If we consider the global need for departure, arrival, and standard vehicle traffic, this is a bit more complex, so we would probably need some high-level synthetic views. This is done by means of properties that you know from Capella, such as the ability to have synthetic functions, higher-level functions, that will summarize, synthesize the global functional analysis that has been defined. Here is an example. We have the same situation as previously. As you can see, we have the full scope because we have added not only train leaving, but also train arriving the station. And we have just summarized it into three different high-level functions, each of them being, of course, possibly subdivided into lower-level details, such as this one, for example. As you can see as well, the exchanges, functional exchanges between functions, have also been synthesized in terms of categories, which are much simpler as compared to the one that we can see here, for example, between this box and all the rest of the functionalizes here, which is to be compared with only those few ones. If we want to go one step further, we can have different levels of synthesis, for example, this one. And here we have a presentation which is a bit more detailed. As you can see, we have split and separated departure procedure management and arrival procedure management according, of course, to the different exchanges with the rest of the system. So as you can see, we can have different level of synthesis as needed. Now let's consider the situation where we have to interface with an external actor. Here that will be the station information system, because this one is imposed to us. We have no choice to use anything else than the interface that the station information system will deliver to us. So we have to analyze it and describe it precisely so as to see whether it has some constraints or consequences on our system design and need definition for the moment. Let's have a look to this one. As you can see, we have just an extract of what we have seen previously, but a bit more detail here, because we have the system itself here, the station information system here, and we have what is expected to be delivered by the information system, such as train leaving information here, and schedule and train statuses, depending on the train's movements. And this is what we expect from it, so translated by functional exchanges between functions. But of course, those information are delivered under a certain form, which is imposed by the station information system. This form is described by this component exchange here that will contain information coming from those two functional exchanges, and we also have the information that this will use a local network so as to be sent from the information system towards the control system itself. So as you can see, this exchange, which is a real implementation of the different functional exchanges, will be carried on the local network, which is here. And of course, we will add any specification information as required, such as the kind of local network. Here it will be a Wi-Fi one, and we've got other constraints that could be that the train schedule service could be delivered under the form or an RSS stream over HTTP, for example. So this is just a way to fully capture all the constraints that an external system may impose on the control system so as to fulfill the communication and describe it precisely. Based on that, we can, of course, analyze whether those information are sufficient for the system functions, and on the other side, whether the system function would need some information that are not present in what the station information system is capable to deliver for the moment. So this is really an important point, as you can see, even at system need analysis level, to have a clear analysis of the external interfaces which are imposed to us. But what is carried inside those different functional exchanges, for example? Let's have a look more precisely to the definition of the data format that are exchanged. So let's consider this one, for example. Here we've got the definition of the information that the station information system will deliver. So it delivers two lists, a list of train departures, another one of train arrivals, and each item in the list will be describing a train movement being defined by the identifier of the train itself, which is string, the quality of service, is it on time or delayed, for example, the station track number where the train will depart or arrive, and the situation in station as well. As you can see, we also have, of course, two information of time, planned schedule, and the estimated schedule, depending on possible delay, for example. So this is a fully detailed description of what is carried in the functional exchanges that we can see here, with no ambiguity, as you can see. If we consider as well the definition of train movements, where we can see the train schedules update and the train leaving information. So as you can see, both are defined by the different data that we have seen. So this is exactly the kind of services or messages that are exchanged using the different data that we had seen previously as described here. Okay. So these are the kinds of services or messages here again. One delivering all the schedules, the time schedules with train arrivals, departure, and also the time when the last schedule has been published. And we have the train leaving information, which is a bit more like an event, which will describe which train will leave and under which conditions, such as track and so on. Here again, we are in the situation of facing different cases that the system has to deal with. So we will have also a set of system mode, as we have seen from the operational analysis. Unsurprisingly, as you can see, it looks really close to the one that we have seen previously with train departure, arrival, and road traffic modes, with the same kinds of conditions, because we are in the same kind of situations. What is different here is the fact that we have seen that we have some feared situation that we want to avoid and that the system has to care about. For example, if we had For example, a vehicle that would be stopped on the crossing, we might need to have an emergency stop, or for any other field situations that were not anticipated. For example, in that case, we will add a new mode, which is to stop in emergency all the traffic. And of course, this raises a question of how do we enter it, probably by means of, for example, an emergency push button, for example, but more important, how we will release and leave this emergency stop mode. So we will create a situation that will bring us back to a standard road traffic mode. But the question is, how will this transition be triggered, and how shall we manage the fact that once the traffic has been stopped, it can be resumed? And this is, of course, a safety-related concern. This is why it's interesting to have this mode analysis at any level, and it can be changed or enriched at any level, as you can see. For example, here, if we consider this one, we have to define some functions that will deal specifically with that, which are to shut down the power supply, to prohibit departure, for example, and to stop vehicle traffic as well. So as we can see, as we have seen when adding this mode, we have to slightly modify the traffic and system monitoring as seen here. Here we have description of the different functions that we have already seen, but here we enrich the system. For example, here we need to give information to the traffic control operators. We have to collect some instructions, which are those who come from the different system elements, and how the system reacts, so as for the control operators to monitor the appropriate behavior of the system itself. So as you can see, we have added that so as to be able to manage, and more important, we have also added these two functions which are in charge of dealing with the new mode that we have added. So shut down the power supply in emergencies so as to stop the trains, no matter where they are and what are their conditions, and of course resume trains power supply so as to leave the mode that we have mentioned. And this functional exchange will be the trigger of the former mode transition that we have defined here. So as you can see, just adding this mode has led us to significantly modify the function behavior expected from the system, especially by adding those two functions. Now, similarly to what we have seen in operationalizes, we have, of course, scenarios that are now adding the system in their definition, as we can see here. Here is an example here that you can see, a bit more complex, of course, as compared to the former one, with the control system now, which has to manage the different actions and functions that he is in charge of dealing with. So interacting in the same way as we have seen previously, by detecting the different vehicles and trains, for example, deciding to stop some, to allow crossing for the train, and to signal the permission or the prohibiting of those different level crossing situations here, as we can see. Here again, this scenario will be probably used for verification and validation purposes as well, because it's a way to check that the system really behaves as specified in this scenario, for example. Regarding a functional change that would define the full procedure of departing, which is a kind of assembly of the former functional chains that we had seen previously. Here we can see them. Here it is, as you can see, we have all the different set of functions that are involved functions from the system and functions from external actors that are involved in the operational process that we have seen in operationalizes to manage departure. Of course, it's here more detailed due to the contribution of the system as expected and described by those system functions here.